Hi guys, welcome to another episode of MrLopezClasses.com. In this episode we are going to continue with our book of Marine Corrosion. And this is the chapter 5. The chapter 5 is about the marine corrosion and the factors that affect the marine corrosion. We are going to check the relative humidity, the aqueous corrosion, the pH level, the alkalinity, the salinity on the seawater, the pH and the acidity and other pollutants, and the phenomenon of the corrosion versus the temperature. It's an interesting chapter because this is the last chapter dedicated to the theory. After that, the next coming chapter, we are going to analyze how the electricity, the leaks affect or accelerate the corrosion. The next coming chapters are wonderful chapters because we are going to use our concept of DC current, AC current, and we are going to identify where is the leak that accelerates the corrosion in that specific area, and how the corrosion is affected when an additional extra current is moving in between the metals. Okay, my friends, once again, I hope you enjoyed this episode. I have a lot of information for you. Okay, my friends, we are going to start to refresh a couple of concepts. What is corrosion? You remember? We said that corrosion is the accumulation of oxidation. Yes? Today we are going to introduce another basic definition. It's the chemical deterioration of a metal. Nice. I like that definition. It's simple. It's the chemical deterioration of a metal. That's good. Corrosion is the disintegration of the metal in a chemical reaction. Yeah, that reaction starts in the surface of the metal. Good definition. All the metals exhibit a tendency to be oxidized. All of them. Not only ferrous alloys, all of them, except gold. You remember? Because gold is gold. Some metals more than other ones. Yes, there are metals more propense to be corroded than other ones. But all of them, at the end of the day, will be corroded. The acknowledge of the location of the metals in the periodic table is critical in order to take decisions about which metal or which alloy is better for marine environment. This is the last sentence of this, and this is this book, The Study of the Periodic Table for Marine Applications. Okay, what is the meaning of corrosion? Salt water is a better conductor of electricity in comparison with fresh water, of course. And we analyzed before in other videos, in other episodes, in other courses, that is basically because the salt water have a lot of minerals, a lot of metals. And those minerals, those metals, suspended in the water, produce that the salt water be an excellent conductor of electricity. Simple. It's too simple. It's not because the salt is not, no. It's because there are a lot of minerals and metals suspended in the salt water. Finito. For that reason, the salt water is good conductor of electricity. Fresh water now is conductor, but it's a poor conductor. Of course, is conductor, but is not an excellent conductor like a salt water. Salt water is a good conductor. For that reason, when you have a problem of high level of salt water in the bilge of your boat, in the engine room, and the salt water reach the level of the batteries, finito. If the salt water touch both terminals of the batteries are destroyed. The batteries enter in short immediately, short to ground. Yeah, okay. Salt water is a good conductor. How can I stop the phenomenon of corrosion? It's too simple. You need to eliminate in the environment all the chlorine, all the salt, and all the humidity, and that's it. No more corrosion. And of course, no more leaks of current. and the process of corrosion is not eliminated, but is practically nothing. In other words, in non-marine environments with no wet areas, dry areas, and additionally no marine environment because it's not salt water, and no chlorine and no salt, the corrosion is practically zero. Yeah, at sea level, with a marine environment, with high concentration of chlorine and salt, the corrosion is accelerated. Yes, if you remove completely the chlorine, the salt, and the humidity, you stop the process. Yeah. There are metals and alloys, metals that like stainless steel, titanium, magnesium, naval bronze, anodized aluminum. Those alloys, those metals, produce a film on the surface, and that film protects the metal. You remember the chromium? What is the film of the chromium? Yeah, it's a chromium oxide, and that film protects the steel and keep the steel free of corrosion. The same with the anodized aluminum. It's a special oxide of aluminum in the surface and protect the aluminum. The same with the bronze, the naval bronze. All of those alloys, they have your self protection. Yeah, because those are considered naval alloys, marine approved alloys. You remember the series of stainless steel, the series 300, especially 304 and 316. Yes, those are special marine grade alloys, and other naval alloys. You remember Tobin bronze, Aqualoy, Monel. What is the other one? Nibral. Those are marine alloys, naval alloys, bronze. Those alloys are approved for marine environment because those alloys minimize the process of corrosion, and those alloys are self-protected. Okay, the oxide in the surface protect the metal. Okay, my friend, we are going to refresh the concept that we have that we study until this moment. The process of corrosion starts with the process of oxidation. The oxygen attacks the rest of the elements in the periodic table because the oxygen, fluorine, chlorine, sulfur, and phosphorus are located in this corner of the periodic table with high level of energy, high electronegativity, and they attack the rest of the people in the periodic table. Other group of people is located here, the alkali elements. Yeah. When the oxygen is combined with this group with non-metals, oxygen plus non-metals, you remember what is the product? Oxygen plus non-metal produce acidic oxide. Alright, acidic oxide. Examples, for example, oxygen and non-metal is nitrous oxides, sulfur oxides, phosphorus oxides, and carbonic oxides, carbon oxide. Those oxides plus water produce nitric acid, sulfuric acid, phosphoric acid, carbonic acid, Acids. Those are acids. And the acids are highly corrosive. This is in the case when you have oxygen and non-metals. You produce acids. And now we are going to check what happens when we have oxygen plus metals. We have oxygen plus metal. We have basic oxides. Now, for example, oxygen plus sodium. Oxygen plus calcium. Oxygen plus sodium is oxygen plus calcium. Yeah, those are basic oxides. The basic oxides plus water produce hydroxides. Hydroxide of sodium, hydroxide of potassium, and other ones. Okay? And those are bases. Nice, no? Oxygen plus metal, basic oxides, and produce bases. But streams are highly corrosive. More acidic or more alkaline, both of them produce high level of corrosion. Yes, my friend, you remember where is used hydroxide of sodium and hydroxide of potassium? You remember that product? Like to clean sanitation system, to clean freshwater systems in your home. That white powder is highly corrosive. Highly corrosive. You need add it and flush immediately. If not, the pipes of the sink in your home is perforated. Highly corrosive. Oh, the same like the acids. With the acids, you have the same situation. Chlorhydric acid, sulfuric acid, nitric acid, phosphoric acid. All of them are highly corrosive, but streams are highly corrosive. For that reason, we are going to study in this chapter what is the meaning of the pH. And how can we check the pH in order to be in the middle, not too much alkali, not too much acid, in order to minimize the process of corrosion. In both extremes, I have high level of corrosion. You need to keep in the middle. You need to select elements in the middle. For that reason, the metals located here in the middle are excellent. Not too much alkali, not too much acid, the transition metals. The transition metals are the preferred metals for everything. For fabricators, for everything. Because the alkali metals are not good, or the non-metals not good, acids, the alkali metals, bases, alkali solutions. Alright? Okay, right now it's clear. Right now I think that you understand the periodic table. This is basically the theory about the location of the elements in the periodic table, how to use those elements, how to select, how to combine. We are going to play more a little later, but this is the fundamental. Okay, my friends. Factors that affect the corrosion. The most important factor in atmospheric corrosion, if the pollution, is the moisture. Yeah, the moisture, the humidity, especially marine humidity, with high level of chlorine and salt, that's the problem. That's the problem. Yes, because in the composition of the salt water, remember, we have a lot of sodium, a lot of chlorine, and other components not good. Sulfur, phosphorus, not good. Yeah? But in general, the factors that affect the corrosion is the moisture. In different forms. The moisture in form of a rain, dew, condensation, or relative humidity, RH, relative humidity. If you don't have moisture, practically you don't have corrosion. The moisture accelerates the corrosion faster. Without moisture, it's difficult to corrode metals. For that reason, the secret is keep dry everything, keep dry and properly bonded. That's the secret, to keep your boat in good conditions. To keep inside of the boat the equipment in good condition. Keep dry the equipment, avoid accumulation of water, stagnant water, avoid dew, condensation of water over the surface, and bonded, drain the current properly. That's it. Simple, finito. This is the secret. And of course, if you have elements in permanent contact with the water, protect those elements with sacrificial anodes. Bingo! That's the process. That's the procedure. Yeah, this is the process. We are going to check a couple of definitions. Dew is water in the form of drops that are in a thin layer covering the objects. That thin layer is because condensation. This is dew. Water stagnation is when the water stops the flow and the water stay over there, is accumulated over there. This is stagnant water. When you have a leak, I have the fuel tank in aluminum, and I have a leak of water, drops, and that water is accumulated in the surface of the tank because the tank is flat, it's not inclined. For that reason, always design those metallic tanks with a little inclination to avoid stagnant water. That's other important factor in the moment of that you design. Incline surface all the time to drain water. Alkaline solutions is a mixture of base solids, you remember? Hydroxide of sodium, hydroxide of potassium, base solids, solved in water. Base solids, hydroxide of sodium, potassium, all of them, plus water, produce alkaline solutions. Simple. The potential of hydrogen is also known the pH scale. And now we are going to try to understand what is the meaning of that. What is the meaning of the pH scale? It's the potential of hydrogen. We are going to check other important concept is about the relative humidity. Relative humidity is defined as the ratio of the quantity of the water vapor present in the atmosphere with respect to the quantity, the saturation of the water at some specific temperature, and is expressed in percentage. We hear every day on the news, oh, the relative humidity today is 80%. Is with respect to the total concentration. A relative humidity of 90% is practically saturated the environment with moisture. The critical humidity level is a variable that depends on the nature of the corroding material. Yes. For that reason, if you have environments like the environments in the Caribbean with high relative humidity, more than 70% constantly, in between 70% and 95% is full saturated, and additionally you select proper materials and proper alloys and proper metals, the corrosion is accelerated. My friends, now you understand why it's important that you study. Now you understand the difference between a marine engineer and a marine technician. The marine engineer study. For what reason? For what reason I can do that or no? Or for that reason this material is good. For that reason it's not possible weld that alloy. This is another important course, the welding class. You need to know about welding. If you are a good marine engineer, you need to know about welding. Welding with arc, welding with MIG, with TIG, with oxyacetylene. That's important. If you are a good welder and a good metallurgical engineer, you are a successful marine engineer. Okay, factors that affect the corrosion. Marine corrosion is affected for many characteristics by the metals. The metal is important, and the straight current. The DC current that is moved on the metals. Let me explain something. What is the meaning of a straight current? A straight current is DC current. It's current that is, you remember static electricity? Static electricity is the energy storage, the energy accumulated on the case of the equipment. Let me explain something. Suppose that you have a dishwasher or refrigerator. All of those appliances, they have an electric motor, AC motor inside. It's an AC motor. We are going to think in the dishwasher. The dishwasher have internally a motor, and the motor is spinning, no, at high speed. All right. When the motor is spinning, the coil of the stator and the rotor jumped some electrons, and those electrons are stored in the case of the dishwasher. No? If the case of the dishwasher is not properly bonded, is not properly connected to the ground, to the bonding system, what happens if you suddenly touch the case of this appliance? You feel that static electricity. Is the electricity accumulated? Is the electricity storage on the case of the equipment? And that energy is stored until somebody touch and drain. Of course, if the equipment is not properly bonded. If the equipment is properly bonded, no problem, because the energy storage is drained constantly into the bonding, and the bonding to the zinc, and the zinc in the water, and the water to the ground. That's it. Finito. But if the bonding is not appropriated, the energy is stored over there. And what happened when the energy is stored over there? What happened with that equipment, with the appliance? In the case of that equipment, for example, the skin is steel, and the screws are in aluminum or copper or other alloy. The similar metals together with energy in between both of them. Static electricity storage over there. This is the worst scenario. You have a marine environment with humidity, and you have a dissimilar metals together, and you have moisture around. What happened with the case of that dishwasher in 2 months? It's completely corroded. In 6 months, eroded. In 1 year, disappeared. You understand? You understand? It's simple. This is the function of the bonding, the grounding cable. Drain that static electricity storage over there. Yes, the static electricity is DC current. Oh, it's coming from AC spinning. Yeah, but those electrons are storage, and right now it's DC. It's a potential difference. Yeah, the static electricity is DC. And is drained through the bonding. For that reason, if you check other definition, if you check the ABYC Electrical Static Guide and other books, they say the grounding, the bonding cable is a non-current conductor, but is used to drain small DC currents, those static currents. That static electricity is drained through the bonding into the grounding, into the zinc, and bye-bye. Yes, yes. This is the static electricity, and this is the worst scenario. For that reason, the bonding is critical. All the metallic elements inside of the boat should be connected with the bonding, and we are going to talk later about that. Okay, right now I feel that we are moving faster in order to understand the phenomenon of corrosion. Regarding to the water, primary factors like the alkalinity, the hardness, and the pH affect the corrosion. The alkalinity, the hardness of the water, and the pH affect the corrosion. Yes, for that reason, the salt water is more propense to accelerate the corrosion than the fresh water. Alkalinity, hardness, and pH interact to determine if the water produces scale or corrosion. Nice. That's true. That's true. And right now we are going to talk about those factors. Those factors. Factors affecting corrosion. A film of dew, that small film of moisture, saturated with sea salt or acid sulfate and acid chloride of a marine atmosphere provide an aggressive electrolyte for the promotion of corrosion. Yes, my friend. Yes, my friend. You have all the enemies. You have sulfate, sulfur. You have a chlorine, acid of chlorine. And the marine environment, the marine atmosphere, and salt water. Oh, fuck. That's the worst scenario. The metal is destroyed. And additionally, a leak of current, or additionally static electricity storage over there. Bye-bye. Finito. Okay? Yes, my friend. For that reason, if you are a good engineer keep the engine room clean, dry. Eliminate all the possibilities of leaks of water. Everything is clean, everything is dry. And everything, all the metals in the engine room properly bonded. You enter in the engine room and you see a professional engine room, like a hospital, completely clean. If not, everything is corroded. If your engine room is corroded, it's because the engineer in that boat is a Mickey Mouse engineer. Don't know about the cathodic protection. Don't know about the cleanness. Yes, simple. It's a bad engineer. Okay. Now we are going to check corrosion versus humidity. What is the meaning of, of course, the humidity increment the corrosion. And once again, the stagnant moisture, the humidity accumulated, accelerate the corrosion in the surface of the metal. Of course, it's simple. It's simple. Once again, you need eliminate stagnant water. water accumulated in the surface of the metals. And you need design appropriated the inclination of the fuel tanks, of the water tanks, of the water makers, the air conditioning equipment, the properly inclination in order to keep the pans, the grills, everything dry. If everything is dry, you don't have corrosion. That's the secret. Keep dry everything. And now we are going to introduce another important concept, is aqueous corrosion. The term aqueous corrosion describes the majority of the problems of metals in contact with seawater. Aqueous corrosion is problems related in between the metals in contact with seawater. That's it. Corrosion by seawater is aqueous corrosion. It's corrosion because the seawater in contact with the metal. Finito. It's an electromechanical process. Yes. And all the metals and alloy, when in contact with seawater, have a specific electrical potential. My friend, don't forget, each metal have your own energy, your own electronegativity. If I have dissimilar metals together, the metal with more energy, the more noble metal attack the less noble. And the less noble, at the end of the day, will be corroded. Simple. If additionally those two metals are exposed or surrounded by salt water, the phenomenon of corrosion is incremented. This is aqueous corrosion. It's basically the corrosion of the metal because the metal is surrounded by salt water. Finito. Depending of the pH of the water, the process of corrosion is accelerated more or less. And right now we are going to talk what is the meaning of that. Yeah, depending of the salinity or the alkalinity. How can I check if it's more alkaline or more acidic? It's a piece of paper used to check the pH of the liquid, the pH of the electrolyte. How the pH affect the level of corrosion? Pay attention. But acids and alkalis are highly corrosive. Both of them produce or accelerate the corrosion. Alkali, I explained to yours, or acid. Both extremes are not good. For that reason, if you have a pH with close to 0, is acid. In this is acid. Or if you have a pH around 14, is alkali in this corner. Alkali or acid. For that reason, the secret is try to be located in this area in the middle of this scale. Not too much acid, not too much alkali. In the middle is a good scenario to reduce the phenomenon of corrosion. To reduce, now stop is practically impossible. How to check the pH? You can check the pH with an indicator. It's a piece of paper. It's a piece of paper, the pH indicator. When the paper is introduced in the solution, change the color. Simple. Each different color indicate the level of pH. You can buy those test strips. In all the marine shops, West Marine, all of them, they sell test strips in Amazon, in internet. I recommend keep in your boat those strips in order to check the level of alkalinity in the solution. Those are similar than the paper strips that you use to check the condition of the coolant. You remember in our diesel course, those strips is basically the same to check the alkalinity of the solution. You remember when you use the SCAs in order to identify if the level of SCAs is good in the coolant. It's basically an indicator of the pH. You remember that one? It's exactly the same like this, okay? In order to check the level of alkalinity. Okay, my friend, and this is the diagram, the specific diagram for the level of alkalinity. Once again, the idea is be located in this neutral position, not too much alkali, not too much acid. And there are a lot of example of alkali elements. Bleach is too alkali, no? And the acid of the battery is too acid, yeah. And there are a lot of examples. Pure water is located in the middle. Pure water, the pH is 7.0. The pure water. For that reason, the doctors recommend drink minimum 8 glasses of pure water per day. 8 glasses in order to keep your level close to zero. Close to the neutral. Neutral is not 0, it's 7. Yeah? Drink minimum 8 glasses of water per day. Pure water, the pH is 7, is neutral. Completely neutral. No? Alkalinity. Alkalinity is the measure of the capacity of the water to neutralize acids. Yes, once again, for that reason you need to drink pure water, minimum 6 glasses of water in order to keep neutralize the excessive acids produced for different reasons, different food. Alkali compounds in the water, for example, bicarbonates, baking soda is an alkali compound, and hydroxides remove the positive ions and decrease the acidity of the water. Yes, my friend, for that reason, when you have too much acidity in your stomach, you prepare a glass of water with bicarbonate. This is an alkali solution. You drink that and you neutralize the acidity. Now you understand what is the reason of that. Okay? The alkali solutions neutralize the acid solutions. Alright? And if you are in neutral, your pH is close to 7. Alright, good. Alkalinity and pH indicator. The pH is an indication for the acidity of the substance, of course. It is determined by the number of free positive ions. Positive ions. My friends, remember, the water is divided in a positive ions and negative ions. Yeah? Water consists of a positive ions and a negative ions or hydroxides. Ah, nice. Positive ions and negative ions. The negative ions are the hydroxides and the positive ions the hydrogens. Why the hydrogen is positive? Because hydrogen is located in group number 1 and normally hydrogen have low level of energy, release the electron and become positive. And the hydroxide absorb and become negative. Negative ion. While more alkaline is the water, more corrosive it is. Yeah? Exactly the same with the acidity. Right? Simple. And now we are going to talk about the salinity, the level of salinity. The level of salinity is measured in parts per total or percentage. A seawater with low level of salinity is around 3.2%. And a seawater with high level of salinity is around 4.0%. 4% is high salinity and 3.2% is low salinity. Normally, in cold waters you have low salinity. Yeah, especially during the summer season when the ice melts. The Red Sea, located in the desert regions, have the highest salinity. Is 40 parts per total, or 4.0%. And the pH of the salt water, when the salt water have high salinity, is in between 8.2 and 8.8. The pH. Yeah, the pH of the water with high salinity is around 8.8. You remember the pH of the fresh water? 7.0. Okay? The pH pure water is 7.0. And salt water is located here. It's practically 9. It's 8.8. It's salt water. Salt water try to go to the alkali extreme. Salt water is more alkaline than fresh water. Simple. Okay, my friend, you like it? This is the salinity and the alkalinity. Once again, the Red Sea with high salinity, 4.0%, the pH is 8.8. This is the pH of the seawater with high concentration of salt, with high salinity. Freshwater and seawater. Seawater is in between 7.8 and 8.4, 8.8, and the average pH of freshwater is 7.0. Yeah, this is a good example. Freshwater is located in the center. The blood in your body is supposed that have a neutral pH around 7. Bleach have a high alkalinity, and lemon juice high acidity, but extremes. That picture is very, very nice. In order to select the liquids, the metals, the environments, in order to prevent the phenomenon of corrosion. Look at this. In regards of the aquatic plants and in regards to the aquatic animals. The aquatic plants take the CO, and with the photosynthesis they increase the alkalinity. And the aquatic animals take the oxygen and produce CO2 and reduce the acidity. The animals reduce the acidity, and the plants increase the alkalinity. The aquatic animals and the aquatic plants. And once again, the pollutants. Once again, sulfur oxide. Sulfur oxide is basically the major. Sulfur dioxide, which is gaseous product of the combustion of fuel, you remember, is produced in the incomplete combustion of the regular petroleum diesel. Contain sulfur, coal, is produced for diesel, gasoline, and natural gas. Is one of the most important air pollutants and contribute to the corrosion of the environment. You remember I explained in the previous episode, you can avoid that situation using biodiesel or eliminating the gas and diesel engines and convert everything to electrical, fully electric. Yeah, you can combine hybrid, and the engine of the hybrid situation with biodiesel. This is a perfect solution. There are other pollutants I explained in previous episodes: nitrous oxide, phosphorus oxide, carbon oxide, sulfur oxide. All of them are pollutants. And the corrosion versus the temperature. Yes, my friends. Each 10 degrees that is incremented the temperature in the ambient, the corrosion activity is double. Yeah, when the temperature increase, the corrosion is affected. Yeah, this is critical. Take in consideration that during the summer, if your boat is improperly protected, if your boat is improperly bonded, if your boat is not clean, if the engine room is not dry, the process of corrosion is accelerated. This is the function of the engineer. Keep the boat clean, keep the boat dry internally, keep the boat properly bonded. That's the next coming chapter we are going to talk about that. I hope you enjoy this chapter.